Hello. Today I want to explain to you the CO2 module. No, in this module now the customers value the emissions your supply chain generate over the world. No, so the idea here presents a new challenge. No, because normally when this option is off, the tendency of the game guides you to consider strategies that are more related with high level service levels, no? So in this case, since now emissions are important and are valued by the customers, and emissions are very related with efficiency. So in this case, the balance goes a little bit towards the efficiency side. So it is not maybe the best decision to play by giving just a good service level, very high, but maybe it will be like a good strategy to balance the service level you give with the CO2 levels you obtain. No, so this is a scenario when your customers are green, no, and they want to have a less harm supply chain for the environment. No, okay. Let me explain now this situation from the sales part, no? From the sales role. If you go to negotiate, no? Now you will see that besides the traditional indicators like service level or shelf life, you will have as well carbon footprint, no? So what's the problem? See, I told you before, if you play the past round with a high service level strategy, probably you push your supply chain to be very responsive, to be very flexible. And that flexibility, that level of responsiveness generates somehow like very high levels of carbon footprint, which is now not valued by the customers. No? They value lower levels. No? So in this round, normally you have to try ways, to find ways to reduce this carbon footprint. No? So that's what I want to explain now. But before doing that, it is important to realize that not all customers value carbon footprint the same, no? So you have to analyze that. No? How do you do that? Just playing, for example, instead of 102, just look this number, no? It's 636. If you calculate with 1, for example, it's going to change. So if you do this exercise with the other customers and see how much they value, for example, an increment of 1 decimal from 1.1 from to 1.2, for example, no? There's going to be a difference in the contract index. So that's a way to assess how much they value, no, this particular trade, no. This is important because I told you before, you have to make a segmentation strategy with your customers. It is not advisable to promise the same to everyone, no? So you have to think about it to which particular KPI give more to a particular customer, no? And these things about the carbon footprint valoration, no, for each customer, it repeats as well for the service level and shelf life. So each customer has different valorations, or their value different, service level, shelf life, and carbon footprint. So they take that into notice and incorporate that into your formulation of strategy, no? So you have to do actually 3 different strategies that are compatible in between for your customers, no? So that's the idea. Okay, let's now move into this screen. You can see this is the situation I was in the previous round, no? In round 1. So it was pretty bad. If I already promised these levels of CO2, okay, my strategy wouldn't work, no? So I managed to improve from this number to this. So I have to make several things, no? First, always a wise thing to do is try to increase the volumes of sales, no? In this case, I played with that. I increased my promotional pressures. I was rewarded because of my past round performance. So they give me an extra 8% of volume of sales. So that helped me to increase the leaders I sell to the market, no? So some of these statements, no, or lines in this statement are somehow not 100% variable, no? So not 100% proportional to this. So they have some part that is somehow fixed. So this means that if you increase this, the parts that are somehow fixed are going to remain about the same. So this number is going to be better, no? So it is always advisable to try to increase the quantity of product you sell, no? It is a good strategy. Another way to do it is to actually identify what are the drivers that affect all these lines, no? So a good strategy is to start from the bigger numbers to the lowest. If we start with this one, for example, for the purchasing number, we will see that the purchasing of components, no? But it is important to tell, just the purchasing. Here is not included the inbound transportation. The inbound transportation is another line, no? In this statement. So, what are the drivers that move this number? Okay, let's move to the purchasing role. If you click here over any supplier, you will see that they have like a small brief, and there is a particular indicator that is called Emission Index. In this case it's 0.97. This tells you that this particular supplier is actually good, performs good in accounts for emissions. From the mainstream supplier, it has a 3% lower performance, no? So in terms of CO2, this is a good decision, no? But remember, here the decisions are interconnected, so do not just consider this CO2 trade, but also consider another things as we talk about it in other videos, no? But it is just to let you know that this number, no, you obtain for each particular supplier, it depends of that emission index, no? What else? It depends on the volumes. And remember, no, the sales you obtain is not the same quantity you need to produce. When you produce as well the obsolete products that are going to be obsolete at some point in your chain. Also, you need to have components that are going to be scrapped because of maybe some failures in the pulp or during the changeover, no? So those components are also consumed and purchased, no? And then also too, you have as well the rejections that you have when a product does not match your expectation. Those are purchased as well, no? So that's an issue. If you reduce the rejections of components, if you reduce the obsoletes that you generate in your products, and also you reduce the losses you have during the product manufacturing process, either in the number of changeover or in the quantity of pulp you reject, this number is going to tend to get lower, no? So, but just to make a summary, normally, no, the obsoletes and the rejection are more crucial in this matter, no? Okay, so what else? What else it depends? So if we have to summarize this, okay, it is important to choose a correct supplier that has a low emission index. It is also important besides selecting a good supplier, to be very efficient in terms of obsoletes and rejections, no? And that's it. You have those things, those particular features in your selection of supplier and performance. This line is going to be well, no? What about inbound transport? In this case, it's not about the product. It is about the carbon footprint they generate during the transportation. So, as the logic may tell you, this depends in the distance of the supplier, no, from the supplier to your manufacturing site, no, and also to the transportation mode they use, no. You may see here, this is the information tab, no. you can see that it depends of the kind of transportation mode. For example, long haul, short haul, or road transportation. The emission index per ton kilometer is different. So road transportation obviously is less efficient than sea transportation. A long haul are more efficient than short hauls. No, the difference between short haul and long haul, I can't recall it right now, but you can look at it on the internet. There is a threshold that you have to meet in order to pass from short to medium haul and then to long haul. No, but normally when you purchase from, for example, China, India, or Asian countries, in this game, it is considered long haul. No, you just take into notice that it may be considered a short haul if, for example, you buy your fruit from Spain, for example, no, and instead of using road transportation, you use ocean transportation. Just to let you know, no. So, as a summary for this, choose a supplier that is close. Again, if you go here, you will see a distance, no, in the supplier. You can see here is 365 kilometers, no. So this is not that far away. Actually, it's somehow close, and this is somehow related with the lead time, no? So the lower the lead time, the closest is going to be your supplier. It is not a perfect rule, but it is good enough, no? What else? Also consider the mode of transportation, and also you are transporting volume, so the volumes depends as well. So if you reduce the obsolete levels, if you reduce the rejections, this number is going to help as well. It's going to be good as well. So these two lines depends on the volume and your supplier selection. This is critical, and these two account for the majority of this number. So if you do a good decisions here, you have half of the game already, no, about CO2 emissions. The next point is about manufacturing, which is the second higher number, no. You have here two kind of lines: energy and cleaning. The energy is related with the hours you use for producing. This is important. For producing, not for changeover, not for breakdown. The breakdown hours and the changeover hours and other hours that are not exclusively used for production are not part of this indicator, no? So if you're able to use, for example, maybe this in production interval tool, no, that is that comes with the game, no, you can calculate how much is your runtime, no. This runtime is proportional to the energy you consume in the case of the boring lines. But remember, this tool is not perfect. It has its downsides, no. So because this tool does not consider the obsoletes and other things, no. So it is better than nothing if you don't know how to use an MRP model, no? So if you reduce the hours you use during the boring process, this number is going to go down. It's going to be lower, no? How to reduce this? Okay, again, volumes. If you reduce obsolete, you're going to need to produce less products that later are going to be scrapped because are obsolete. So that helps to reduce the hours, but also the speed of the line. So if the line is very fast, each hour that it functions produces more. So this penalizes you for each hour. So if you're able to produce at a higher pace, it's going to be better for this number, no? This works the same way for the energy of mixers. But remember, in the mixer you have two time consumption activities: mixing by doing the batches, and also during the cleaning you consume hours. But remember, as well as the boring lines, only the hours you use for produce in the case of the mixers are for making the batches are the one that affects this number, no? If you go, let me use this instead. If you go to the operation role and go to the mixing, for example, you will see that each machine has a consumption of energy, no? A kilowatt hour. Okay, anyone that is an engineer know that this is not a correct dimension, no? Because the power of a machine is measured in kilowatts. So this is somehow the consumption maybe for an hour, but still, no? Okay. So if we go back here, no? We at this point we know how to calculate this number, but we don't know how to calculate those, no? In this case, cleaning the boring lines and cleaning the mixer depends in one factor, the number of changeovers you have. The more changeovers you perform, the higher are going to be those numbers. And also depends on particular characteristics of each machine, no? If we go again to this option, you will find that you have emission for cleaning as well. So if you choose another machine, these two numbers, no, the energy users per hour, okay, no, you're right, this is correct, yes, because it is reading in this way, sorry. And emission for cleaning, those changes. So it depends on the machine, and also these numbers, no, because if your machine is very fast, in the case of the mixer, it runs a batch much faster, or maybe with the same time, but in a higher volume, is going to be best for reducing the reduction of these numbers, no? So, as a summary for manufacturing, what to do? Okay, try to produce faster by using less running hours, and also try to do less changeovers, and select machines that tend to be more efficient about emissions, no? Normally, the low volume machines, the slow machines, in terms of CO2 are the worst, because they tend to they tend to use more hours because are slow, no? It's not always the same. Remember that, as I told before, this game depends in so many connections, so what I'm telling you, it is just approximation. You have to do the numbers. That's the final thing, no? Let's now move into the next big number, handling, no? And here you have two important numbers, the scrap of finished products and the scrap of projected pulp. The scrap of finished products depends in the level of obsolete. If you have higher level of obsolete, you will have to scrap a lot of finished product, no? So here's very simple, no? Just don't produce that much of obsolete, no? Please don't confuse this with this, because the obsoletes, when you purchase it, the product itself generates a CO2 footprint, no? But in this case, it is not about the product, it is about the process to scrap it. So it is different, yeah? In a similar fashion, when you are in the boring line and you produce a particular product, no? This product goes to inspection, and if the levels are not okay, you have to reject the pulp. You can see that in this report, in the mixing and boring, no? So you can see, okay, startup, no, okay, no, sorry. You cannot see it here, but you can see it if you download the full report in the boring line section. You can see how much was the rejection of pulp, no? In monetary terms, no? So, in this case, if you want to reduce this, you have to be more effective in terms of reducing the quantity of pulp you reject. So how to obtain that? By purchasing better quality of pulp or making inspections in your inbound warehouse prior to production. So that's advisable to reduce those numbers. I don't want to spend time in those two because are very small, but this one depends on cleaning, no? So it depends on the volumes of drums, IBC, and tons that you manage during a particular round. But it is so small, the number, that it doesn't worth the effort to try to calculate in an exact way this number, no? Okay, let's move now to the next one, distribution. You have this for each particular customer, and what matters here? Let's move to the sales option. If you click here in the info for each particular customer, you will see now that they have a distance, no? So you cannot select actually customers. So this is just it. It is what it is, no? But you have to account this, no? Not all customers in average are in the same distance from their main DC, no, the distribution center, no, for each customer. So you have to account that, no, because the transportation, no, for distribution costs different as transportation for components. This is logical, no, because it is not the same to just make a direct route between a supplier to your manufacturing site. It is not the same like making a route for distributing things, because you have many stops, you go to urban settlements that are very crowded, and it is not that easy because of traffic. So it is normal that CO2 emissions for distribution is higher than for transportation between a supplier and a customer, and a customer that produces, no? Not in this case that you distribute to a customer as well, but that it is a retailer, no? It is quite different. Okay. So what else? This depends on the volumes, but the volumes are proportional to the sales, so you cannot do that much about that. But also depends in how efficient you are in the volume you take advantage in your transportation. If you transport trucks that are like less than fully loaded, no, it means that you're going to move some air, no, and with that dead weight of the truck. So that's not efficient. So if you tend to ship not full trucks, this number tends to be higher. How to improve that? When you negotiate in the sales option, you can negotiate the trade unit, no? Instead of pallet layer, maybe to make this more efficient, just do it by pallet, no? But this will create you a problem, because the contract is going to get reduced. But you have to account if this reduction actually helps you. It is harmless that having this number high, no? Again, make the numbers, no? But this number depends on the distance to the customers, the volumes you move, which you cannot do anything because this is your sales, no? It is not advisable to reduce the sales to reduce, no? It will not be wise. It will be wise. But also, you can change the trade unit to make more efficient the cubic utilization in your trucks. That's the idea, no? And finally, I'm going to explain the inbound and outbound at the same time, because it is almost the same logic. The pallet locations depends on how much pallets you have allocated for each warehouse. If you go to this screen, you will see that you have a yearly emission for pallet location of 90, no? And yearly emission per tank, no? So in this case, you use this 90 and you multiply it by the numbers of pallet locations. In this case, it's 900. So 90 multiplied by 900 over 2, because this is yearly, and each round is 6 months, no? And in the tank yard is the same, and with the pallet locations, it is the same. About the overflows, it's similar, because it depends on how much overflow do you generate in your warehouse, no? But it is not a big number normally if you're managing well your warehouses, no? So what's the idea here to optimize this? Or try to reduce the need for pallet allocations in your warehouse or tank allocation in your warehouse. That will help you to reduce these numbers. But remember, these two numbers are not that important, no? I think that if you work you fine tune this and this very well, and maybe the distribution, the other two doesn't matter that much. Maybe by trying to optimize this, you will ruin something else. So just take this into account. And finally, you have the overhead, which is, as far as I know, it is fixed. I can foresee that this is not fixed. Actually, may depends on the quantity of customers you have, the quantity of suppliers or components. So if at any point you have to increase the number of components, decrease your supplier, increase it, or eliminate maybe some products you sold to a particular customers, yes, maybe this will reduce or change, no? But since my strategy was the same, this is fixed for me, no? So at the end of the day, you sum everything and divide by the volume of sales. Remember, it's always important to try to sell more if you want to obtain a better number, because some of these lines are somehow fixed, no? So that will help to increase the number, reduce the number. So it is crucial, just to make a closure, no? To understand how this CO2 module works, no? In order to be able to know how to fine-tune or move the levers that are going to create this decrease. I was forgetting to something important. In operations, okay, this module comes with help as well, no? They throw you some lifesavers. In the boring line, they will give you the option to use some projects, decrease water usage, decrease the startup productivity loss. All these help you to reduce increase the efficiency of your processes. So at the end of the day, this manufacturing line gets reduced. Well, that's all for now. Thank you very much for your attention. See you around.